Real-life Iron Man is closer than you think. A soldier straps into a mechanical suit. In seconds, 200 pounds feels like 10. He lifts ammunition crates that would normally require 3 people. Hours of heavy labor and he's barely sweating. This isn't CGI. This is the Sarcos Guardian XO, and the US military just bought it. But here is what they are not telling you. The Pentagon already spent $80 million trying to build a super soldier suit and it failed spectacularly. Military exoskeletons are wearable robots that amplify human strength. Think mechanical limbs wrapped around your body, powered by electric motors or hydraulics. The Sarcos Guardian XO can lift 200 pounds, while the operator feels like they're relifting just 10 pounds. The 150-pound suit transfers weight directly to the ground through its own legs. You strap yourself to the robot, not the other way around. But here's where it gets interesting. There are 2 types: full-body suits, like Guardian XO, that turn you into a human forklift, and partial systems like Lockheed Martin's ONYX that target specific body parts. ONYX uses AI-powered knee actuators and sensors to reduce stress on soldiers' lower backs and legs. A University of Michigan study proved ONYX users carrying 40-pound backpacks exerted significantly less energy climbing. The military's been chasing this technology for 20 years. They've spent hundreds of millions. Some programs succeeded. Others became cautionary tales worth examining closely. The physics is straightforward, but the engineering is brutal. Guardian XO has 24 degrees of freedom, 24 powered joints that use 4 sensors to detect every motion you make. When you move, the suit moves with you instantly, with 0 noticeable lag. According to Sarcos, the exoskeleton amplifies operator strength by up to 20 times. The secret: power consumption dropped from 6,000 watts 10 years ago to under 400 watts today. That's less power than your microwave. Hot swappable batteries provide up to 8 hours of operation. The suit goes 3 miles per hour, not fast, but sufficient for industrial and logistics work. ONYX works differently. It learns your movements using AI and delivers the right torque at the right time, assisting when you climb steep inclines or drag heavy loads. The system anticipates your next move before you make it. But there's a catch. Early prototypes exhausted users instead of helping them. Why? They fought against the natural rhythm of human movement. Getting the timing wrong turns an exoskeleton into what MIT engineer Hugh Hare calls a fancy exercise machine. That's exactly what happened to the military's first major attempt. The US military has tested dozens of Some work, most didn't. Here are the systems that mattered. Guardian XO, US Marines, Air Force, Navy, and Special Operations Command all signed contracts to test it. Delta Airlines deployed it in January 2020 for ground operations. It's real. It works. But it costs $100,000 per year to rent. ONYX. The U.S. Army awarded Lockheed Martin $6.9 million in 2018 to enhance ONYX for soldier demonstrations. Soldiers tested it at the 2019 Association of the U.S. Army Conference. Reporter Paul McClary walked the floor, wherein it described it as a robotic, motorized knee brace that takes weight off injury-prone knees. The applications: not combat, logistics, shipyard maintenance, loading ammunition, moving supplies. These aren't battlefield weapons, they're industrial tools adapted for military use. Then there's TALOS, the Tactical Assault Light Operator Suit, the one that was supposed to change everything. In 2013, Special Operations Commander Admiral William McRaven announced plans for a bulletproof supersuit with enhanced strength, tactical awareness, and invincibility. Media called it the Iron Man suit. By 2018, it was supposed to be operational. By 2019, it was dead. SOCOM spent at least $80 million over 5 years on TALOS. The project aimed to integrate an exoskeleton with ballistic armor, health monitoring, and battlefield computers into one seamless suit. What killed it? First, power. A Center for New American Security Analysis concluded that current battery technology cannot generate sufficient power to carry the intense load. The concept required covering a user in hard armor for extended infantry operations. The suit needed to generate 12 kilowatts for 12 hours while weighing under 400 pounds. Impossible with today's batteries. Second, integration complexity. The exoskeleton proved impossible to design to SOCOM specifications because of the amount of interoperability needed between it and all other necessary suit components. 40 separate joints, 14 powered, all needing to coordinate perfectly. The systems engineering challenge was insurmountable. Third, weight. Early prototypes weighed 600 to 700 pounds. Soldiers couldn't move naturally. SOCOM spokesman Navy LT Philip Chiti stated the prototype was not suitable for operation in a close combat environment. But TALOS wasn't the only failure. The Human Universal Load Carrier HULC was shelved after proving impractical, exhausting users instead of supercharging them. Lockheed Martin's predecessor to ONYX simply didn't work. TALOS. Full-body armored combat suits remain science fiction. Partial systems targeting specific tasks. Those are real and deployable now. But there's a wild card. Materials science. Graphene-based actuators, super compact fuel cell spray-through technologies could change the equation overnight. When battery energy density doubles, everything becomes possible. Here's the uncomfortable truth. Soldiers are already superhuman compared to a decade ago. Night vision turns darkness into day. Body armor stops bullets that would have killed your grandfather. Drones give you eyes in the sky. GPS guides bombs to within meters. Exoskeletons are just the next step in a century-long augmentation process. But the Hollywood fantasy Iron Man combat suits won't happen. Not in 10 years. Probably not in 20. SOCOM officially announced in February 2019 that the TALOS supersuit concept was not feasible. With the full-body exoskeleton prototype not mature enough for SOF needs, what will happen? Specialized augmentation for specific tasks. Logistics crews become 20 times stronger. Maintenance personnel work longer without injury. Infantry soldiers marched farther before exhaustion. The super soldier won't be one person in a magical suit. It'll be squads of enhanced humans, each optimized differently. The loader with Guardian XO, the rifleman with ONYX supports the squad leader with augmented reality displays. Superhuman doesn't mean invincible. It means optimized using technology to push human performance slightly beyond natural limits. while accepting those limits still exist. The military learned this the hard way. After $80 million, they discovered you can't engineer your way past physics, power, and human physiology. At least, not yet. So, is the super soldier suit real or hype? Both. The technology is absolutely real and improving rapidly. Soldiers are using it right now, just not the way Hollywood imagined. And maybe that's the point. Real innovation doesn't look like movies. It looks like incremental improvements that compound into revolutionary capability over time. The exoskeleton that makes soldiers superhuman exists. You just won't recognize it because it doesn't come with repulse arrays and a witty AI assistant. It comes as a 150-pound metal frame that lets one person do the work of three. And sometimes, that's all the superpower you need.